Greetings. Hello everyone. Welcome back to Pettaka Technologies. In this video, we will be counting down the top 10 most important DAX functions that every Power BI user should know. From calculate to switch, we will cover the most powerful and commonly used functions and explained with real-time examples to help you unlock your advanced data analysis and visualization capabilities. Whether you are a Power BI beginner or an experienced professional, this video will help you to simplify complex calculations and enhance your data models to boost your report performance, and you can make more informed business decisions. So let's start and explore the top 10 DAX functions that will transform your Power BI experience. DAX used to create formulas and expressions in Power BI to enable users to perform complex calculations, data analysis, and data modeling. It is allowing for more meaningful insights and better decision making. Let's start. The calculate function is a powerful function in Power BI that allows you to perform calculations on a table or measure and applying filters and modifications to the calculation. Let me explain you with an example. In this data source, we have two columns, color and sales amount in product table. Go to table tools and select new measure to create a measure for calculating the total sales only for blue color in the product table. Rename this measure as blue revenue and write the DAX to calculate the total sales. Select calculate DAX function to perform calculations on your data. The syntax for the calculate function is expression, comma, filter. Calculate evaluates the expression or calculation specified as the first argument. For example, we select sum function in DAX to calculate the sum of sales amount column in product table. Example, choose sales amount column, close the parenthesis, comma. Next, calculate applies the filters specified as additional arguments to the expression. These filters can be table filters or measure filters or complex filters using logical operators. Example, choose color column and give condition using equal to symbol and type blue within double quotes, close the parenthesis and commit. This sum with condition formula in Power BI calculates the sum of a column but only for rows that meet a condition blue in color column. The final sum is returned as the result of the calculate function. Let me explain you clearly. Sum of sales amount calculates the total sales. Then calculate applies a filter to only include rows where color is equal to blue. The result is the sum of sales for the blue color only. This formula allows you to easily filter and sum data based on specific conditions, making it a powerful tool for data analysis in Power BI. Let's visualize this measure output in the table visual. Go to report view, select table visual and drag color column, drag sales amount column, drag blue revenue measure. Let's make it in focus mode. Now we can see three columns: color, sum of sales amount, and blue revenue measure provides sum of sales amount only for blue color. Let me make it bigger. Now you can see that columns clearly. The filter function is a powerful function in Power BI that allows you to filter rows in a table based on a specified condition. It allows you to select only the rows that meet certain criteria and discard the rest. Let me explain you with an example. In this data source, we have 5 columns: name, age, country, region, and sales amount in sales table. Go to table tools and select new table to create a calculated table to store filtered rows where the value in the age column is greater than 40 from the sales table. Write the DAX to filter rows greater than 40. Select filter DAX function to perform filters on your data. The syntax for the filter function is table, comma, filter expression. The filter function takes two arguments: the table to filter and the filter expression to apply. We use a logical expression that specifies the filter criteria. The condition is evaluated for each row in the table. If the condition is true, the row is included in the filter table. If the condition is false, the row is excluded from the filter table and the resulting filter table will return. For example, we select sales table to filter rows from sales table, comma, we enter filter condition as age column greater than 40. Close the parenthesis, commit. This filters only two rows because only these rows that met greater than 40 criteria and discard the rest. This expression is calculated for each row and resulting in a value for each row. Finally, filter function included the row if the condition is true, else the row is excluded from the filter table. Let me explain you with one more example to filter rows by multiple conditions. Edit this DAX and we use logical and operator to perform logical conjunction on two expressions. If both expressions evaluate to true, the AND operator returns true. If either or both expressions evaluate to false, the AND operator returns false. We give another filter condition as country column is equal to, within double quotes, enter USA. Close the parenthesis, commit. This filters only one row because only this row that met greater than 40 criteria and country is USA and discard the rest. Let me explain you with one more advanced filter criteria. In some scenario, we might want to filter rows based on multiple criteria within the same column. In such scenario, we use this advanced filter criteria. For example, you want to filter rows where the age is 33, 36, 39 and 41. In this case, we can't use greater than or lesser than operator. Instead, We use in to filter by list of values. Let's remove this condition and we use age column and use in within flower brackets. Enter 33, 36, 39 and 41. Commit. This expression is calculated for each row and filter rows that meet these conditions. The Sumx function is a powerful aggregation function that allows you to calculate the sum of an expression evaluated for each row in a table. Let me explain you with an example. In this data source, we have two columns, quantity and price in sales table. Go to the table tools and select new column. To create a new calculated column, then calculate the total sales amount by multiplying the quantity and price for each row in the sales table. Rename this column as total and write the DAX to calculate the total sales amount. Select Sumx function in DAX to calculate the sum of an expression evaluated for each row in a table. The Sumx function in DAX is used to return the sum of quantity and price column values. The syntax for the Sumx function is table, comma, expression. Sumx starts by selecting the table specified in the function. Example, we choose sales table, comma, Sumx iterates over each row in the selected table, one row at a time. For each row, Sumx evaluates the expression specified in the function. Example, choose quantity column and in Power BI we use asterisk symbol to multiply two column values and choose price column. From sales table, close the parenthesis, commit. This calculates the total sales amount by multiplying the quantity and price for each row in the sales table. This expression is calculated for each row and resulting in a value for each row. Finally, Sumx adds up the values calculated for each row. Then those values are summed up to produce the result. The final sum is returned as the result of the Sumx function. Let me explain you clearly. Sumx iterates over each row. Row 1 2 into 10. Row 2 3 into 20. Row 3 4 into 30. First row result is 20. Second row result is 60. Third row result is 120. Then it adds up the result of each row. 20 plus 60 plus 120 is equal to 200. The result of the Sumx function is 200, which is the sum of the calculated values for each row. The Averagex function is a powerful aggregation function that allows you to calculate the average of an expression evaluated for each row in a table. Let me explain you with an example. In this data source, we have two columns, quantity and price in sales table. go to Table Tools and select New Column. To create a new calculated column, to calculate the average sales amount by multiplying the quantity and price for each row in the sales table. Rename this column as Averages. Then write the DAX to calculate the average sales amount. Select Averagex function in DAX to calculate the average of an expression evaluated for each row in a table. The Averagex function is DAX used to return the average of quantity and price column values. The syntax for the Averagex function is table, comma, expression. Averagex starts by selecting the table specified in the function. Example, choose sales table, comma, Averagex iterates over each row in the selected table, one row at a time. For each row, Averagex evaluates the expression specified in the function. Example, choose quantity column, and in Power BI we use asterisk symbol to multiply two column values and choose price column, close the parenthesis and commit. This calculates the average sales amount by multiplying the quantity and price for each row in the sales table. Select the averages column, change the format to decimal number. This expression is calculated for each row and resulting in a value for each row. The final average is returned as the average of quantity and price. Let me explain you clearly. Average at iterates each row. Row 1, 2 into 10, 20. Row 2, 3 into 20, 60. Row 3, 4 into 30, 120. Then it adds up the result of each row. 20 plus 60 plus 120 is equal to 200 and divided by 3. The result of the Averagex function is 66.67, which is the average of the calculated values for each row. The all function in Power BI that allows you to remove all filters from a table and returning all rows, it like a reset button for your filters. Let me explain you with an example. In this data source, we have 5 columns: name, age, country, region, and sales amount in sales table. Go to Table Tools and select New Measure to create a measure to calculate the total sales amount across all regions and ignoring any filters. We name this measure as All Measure and write the DAX to calculate the total sales. Select Calculate function in DAX to perform calculations on your data. The syntax for the calculate function is expression, comma, filter. Calculate evaluates the expression or calculation specified as the first argument. For example, we select sum to calculate the sum of sales amount column in sales table. Example, choose sales amount, column, comma. Next, we need to close this parenthesis, comma. Next, calculate applies the filters specified as additional arguments to the expression. These filters can be table filters or measure filters or complex filters using logical operation. For example, we select all function in DAX to remove all filters from a table and returning all rows. The all function returns all the rows in a table or all the values in a column and ignore filters. The syntax of all function is table name or column name. We can select either table or column as parameter. For example, choose sales table, close the parenthesis, commit. This expression removes all filters from sales table and return all rows. Let's visualize this measure output in the table visual. Go to report view, select table visual and drag name, sales amount and all measure to columns field. Now we can see three columns: name, sales amount and all measure. It removes all filters from the sales table and it provides output by ignoring filters. Instead of sales table, if I select age column, then it will remove filters only for age column and not for complete table. Select the measure and let's replace this sales with age column, commit. Now if you see, filters are not applied. It is not removed all filters and it applies filters for age. Now select all measure and make it as sales. Let's copy this. Next, let's see the difference between all and all selected functions in Power BI. Create a new measure and paste it. Name it as all selected and replace all function with all selected and choose region column, close the parenthesis, commit. This expression calculates the total sales amount for the selected region and ignoring any filters. To understand it better, let's create a slicer. Let me make it smaller. Create slicer. Drag it here. Drag region column to field. Now make it a little topper. If I select north, before that select table and we will drag this all selected measure to columns. make it smaller. Let's zoom out a little bit, make it smaller, slicer. And now if I select north, it produces the result for north. And if I select south, it produces result for south. I hope you understand the difference between all and all selected. Let's remove this slicer, make this table a little bit bigger. Next, let's see the difference between all and all except functions in Power BI. Create a new measure and paste that value and rename this measure as all except and replace all with all except. The syntax of all except is table name, comma, column name. For example, choose sales table, comma, choose region column, close the parenthesis, commit. This expression shows amounts by region and ignoring filters from all columns except region. Select the table, drag all except measure and place it here. Now make it little bigger. We can see that result all except returns the same. If I enter, if I drag region to columns, now you can see the results are changing. We can also use multiple filters in all except. For example, let's provide another filter as country column. Select all except and choose comma sales country, commit. And now if I drag country column to read columns and let me expand it. Now all except measure are changing the result based on the column filters, and it is not removing the filters for except two columns. The Maxx function is Power BI function that returns the maximum value of an expression evaluated for each row in a table. Let me explain you with an example. In this data source, we have two columns, quantity and price in sales table. Go to table tools and select new column to create a new calculated column. Then to get the maximum sales amount across all rows by multiplying the quantity and price for each row in the sales table. Rename this column as maximum and write the DAX to get the maximum sales amount. Select MaxX in DAX to find the maximum of an expression evaluated for each row in a table. The Maxx function in DAX is used to return the maximum of quantity and price column values. The syntax for the max function is max starts by selecting the table specified in the function. Example, choose sales table, comma, maxx iterates each row in the selected table, but one row at a time. For each row, maxx evaluates the expression specified in the function. Example, choose quantity column, and in Power BI we use asterisk symbol to multiply two column values and choose price column, close the parenthesis, commit. This returns the maximum sales amount by multiplying the quantity and price for each row in the sales table. This expression is calculated for each row and resulting in a value for each row. The final maximum value is returned as the result of the maxx function. Let me explain you clearly. Maxx iterates each row, row 1 2 into 10 20, row 2 3 into 20 60, row 3 4 into 30 120. Then it returns the maximum from 20, 60 and 120. The result of the maxx function is 120, which is the maximum of the calculated values for each row. Alternatively, you can use minx function in DAX to return the minimum of quantity and price column values. Create a new calculated column and name this calculated column as minimum. Then write the DAX using minx function. Minx syntax is table, comma, expression. We select sales table, comma, then select quantity column into price column. Close the parenthesis, commit. This returns the minimum sales amount by multiplying the quantity and price for each row in the sales table. It returns the minimum from 20, 60 and 120. The result of the minx function is 20, which is the minimum of the calculated values for each row. The if function in Power BI tests a condition and returns one value if true and another value if false. Let me explain you with an example. In this data source, we have two columns, quantity and price in sales table. Go to table tools and select new column to create a new calculated column to test if multiplying the quantity and price for each row is less than 20 or not. If less than 20, then give flag as low, else flag as high in the sales table. Rename this column as flag and write the DAX to test the condition. Select if to test a condition in a table. The syntax for the if function is if starts by logical test. Example, select quantity column multiply by price column. Then comma, we need to give condition, so We give condition as less than or equal to 20, comma. If this condition is true, then it should return low, comma. If this condition is false, then it should return high. Close the parenthesis, commit. This returns the value based on the condition test by multiplying the quantity and price for each row in the sales table. Let me explain you clearly. Row 1, 2 into 10, 20. Row 2, 3 into 20, 60. And row 3, 4 into 30, 120. Only first row met the condition less than or equal to 20. So we got low flag. For others, we got high flag. Alternatively, you can use Iferror function in DAX to return a value if an expression evaluates to an error. Create a new calculated column and name it as error handling. We use the Iferror function in DAX to replace errors with meaningful values or messages. The syntax for the Iferror function is value, comma, value if error. For example, choose quantity column, multiply by price column. We divide this multiplication by 0, comma. In value if error, we enter 0, close the parenthesis, commit. This returns 0 because by multiplying the quantity and the price for each row in the sales table and divided by 0 returns infinity error as output. So if error occurs, then alternative result 0 will be the output of the Iferror function, which is 0. The switch function in Power BI evaluates an expression and returns a value based on a set of conditions. This function can be used to avoid having multiple nested if statements. Let me explain you with an example. In this data source, we have three columns: year, month number, and sales amount in sales table. But we need to get the month name from month number. For that, we will create a new calculated column. Go to Table Tools and select New Column to create a new calculated column to get month name based on month number. Rename this column as month name and write the DAX to get month name. Select switch to evaluate an expression and return a value. The syntax for the switch function is switch starts with an expression that returns a single scalar value and second parameter is value. If that value is true, then it will return that result. Otherwise, it will return the else value. Example, choose month number column from sales table, comma, shift enter. Now we enter 1. Then it should return Jan. Enter 2. If the value is true, then it should return Feb. comma, enter 3. If the value is 3, then it should return March. Enter 4. If the value is 4, then it should return April. If all these conditions are not met, then we will provide else condition as unknown. We'll give unknown. Close the parenthesis, commit. This returns the month name for each month number based on the specified condition. Let me explain you with another example. We use the switch function to replace multiple nested if statements. This is accomplished by setting expressions to true. For example, we compare year column on sales table to identify previous year, current year, and future year. Go to Table Tools and select New Column to create a new calculated column. Name this column as Sales Of and write the DAX using the switch function and choose True, comma, choose year column from sales table and give condition as less than year of today. Close the parenthesis, comma. If this condition satisfies, then it should return previous year, comma, shift enter. Let's give another condition. Choose year column. Now the condition is equal to and year of today. If this condition satisfies, then it should return current year, comma. Let's give one more condition. Select year column and give condition as greater than year of today's date. And if this condition satisfies, it should return future year. If all these conditions are not satisfied, and it should return result else result as unknown. Close the parenthesis, double quotes, and commit. This returns value based on the condition provided. The order of values matters. For example, create another calculated column and name it as category. Then we use the switch and true, comma, choose sales amount column less than 1000. If this condition satisfies, then it should return A, comma, shift enter, select sales amount column. Now give another condition as less than 100. If this condition satisfies, then we give B, else it should return C. Close the parenthesis, commit. This expression is never return the second result because the first value is less restrictive than the second. So the result in this example is always A or C, but never B. Alternatively, if you give a missed data type as condition, then it returns an error. Instead of B, if you give 2 and commit, it returns an error because the data types in the result arguments are different. Keep in mind that the data types in all result and else arguments must be the same. The related function in Power BI returns a value from a related table based on the current rows relationships. Let me explain you with an example. In this data source, we have three columns: sales ID, customer ID, and sales amount in sales table. But we need to know the purchaser name for each sales ID. For that, we will create a new calculated column. Before creating column or writing DAX, we need to make sure that whether relationship between sales table and customer table is active or not. For that, go to Modeling tab. Here we can see that many to one relationship is already active between sales table and customer table. Double click this line and it will take you to the edit relationship window. We can see from table is sales table and to table is customer table. Many to one cardinality is selected and cross filter direction is single side. If you want to know more about this cardinality and cross filter direction, please do comment in this video and we will make a separate video on these topics. Now save it, go to table view and go to table tools, select new column to create a new calculated column to get a customer name from the customer table. Rename this column as purchaser name and write the DAX to get value from related table. Select related function in DAX to get value from related table. The syntax for the related function is: related function starts by selecting column name. Example, choose customer name column from customer table. We can see this option because we already created the relationship between these two tables. If the relationship is not created, then these options will not be shown. Close the parenthesis, commit. This returns the customer's name from customer table related to the customer ID in sales table. Let me explain you clearly. Power BI navigates from the current table sales to the related table customer using the defined relationship. Then it retrieves the value from the specified column customer name in the related table. Now the value is returned to the current table sales for use in calculations or visualizations to avoid complex calculations and data merging. It ensures accurate relationships between tables and easily access related data for analysis. By using the related function, we can easily access and analyze related data in Power BI. In some scenario, we want to add the total sales for each customer. In such scenario, we can't use this related function. Instead, we can use related table function. The related table function in Power BI returns a table of related rows from another table based on the current rows relationships. Let me explain you with an example. In this customer table, we have two columns, customer ID and customer name. We want to calculate the total sum of sales for each customer. For that, we create a new calculated column like related function for related table function also need to make sure that the relationship between sales table and customer table is active. Go to table tools and select new column to create a new calculated column and name it as total purchase. We use the Sumx function in DAX to calculate the total purchase of each customer. Then we use related table function and choose sales table, comma, close the parenthesis, comma, choose sales amount column from sales table, close the parenthesis, commit. This returns total purchase of each customer, and if there is no purchase made yet, then it will be blank. Let me explain you clearly. Go to sales table, customer ID, triple one made three purchases, 100, 200 and again 100. So total purchase is 400. Customer ID 113 made only one purchase for 300. So total purchase is 300. Customer ID 114 made two purchases for 100 and 200. So total purchase is 300. The Rankx function in Power BI returns the rank of a row within a table based on specified column or expression. Let me explain you with an example. In this data source, we have three columns: year, month number, sales amount in sales table. But we need to get the rank for each sales amount. For that, we will create a new calculated column. Go to table tools and select new column. Rename this column as ranking and write the DAX to get rank. Select Rankx. The syntax for the Rankx function is table, comma, expression, comma, value, order, ties are optional. Choose sales table, comma, choose sales amount column to create rank based on sales amount, comma, we exclude this value parameter, comma, select descending to create rank in descending order so that it will allocate the rank from high sales to low sales. Close the parenthesis and commit. This returns the rank of each row in the sales table based on the sales amount in descending order, which means highest value equal to 1. Select sales amount column, right click, choose sort descending. If you notice, for row 5, row 6 and row 7, sales amount is 40,000 and same rank 5 is allocated for each row. And if you see row 8, for 30,000 sales amount, rank 8 is allocated instead of rank 6. This is because by default Rankx skip the ranking if there is any tie value in data. The next rank after a tie is the rank value of the tie plus the count of tied values. For example, 3 values are tied with a rank 5. Then the next value will receive a rank of 5 plus 3 is equal to 8. To avoid that, what we can do is go to ranking, edit this DAX, next to descending, enter comma, choose dense, commit. Now we can see the ranking for tied values without skipping. We got rank 6 for row 8, 30,000. Previously it was rank 8 and accordingly following values ranking also changed. That's it. Now you can try all these top 10 DAX functions with different tables and columns in your Power BI reports. Remember, practice makes perfect. Don't be afraid to try new things and make mistakes. Thank you so much for watching this tutorial on top 10 Power BI DAX functions. I hope you found it helpful and informative. If you want to learn more about Power BI and DAX, make sure you subscribe to this channel for more tutorials and Power BI tips and tricks. Don't forget to hit the like button and leave a comment below with any questions or suggestions for future videos. Thanks again for watching and we will see you in the next video.